Alright, so today I want to talk about counting principle, combinations, and permutations. But the thing I really want to get through today is when we use each one. So I'm going to put 3 examples on here for now. So we have a party, and we serve hot dogs, hamburgers, and pork chops with either Pepsi, Mountain Dew, Coke, or Sprite. How many combinations can be made? So there's our first example. Question mark. Second one. We have a swim meet for regionals. There are 10 competitors, and the top 3 advance to the final round or the championship. How many combinations can be made of players advancing? Alright, and then our third one is going to be very similar to the second one. We have a swim meet for regionals, 10 competitors, and the grand prize is first with gold, second with silver, and third with bronze. How many combinations can be made of first, second, and third place? So the key here is, how do we know when to use each one of these? Because we have to understand what counting principle is, what combinations are, and what permutations are. And basically, counting principle is just where I'm putting things together and trying to count how many combinations made. And combination, okay, so I'm going to go back to the top here. A combination is where order does not matter, while permutations are where order matters. Now, to be honest here, number one, since permutations and combinations talk about order, that means that either someone's going to be placed somewhere, you're going to be writing something, someone's winning a competition, things like that. That's order. Or you line up in line by age, things like that. Those are order. Okay, but for number one here, if we go to a party and we want to get a hot dog and a Pepsi, doesn't matter what order I get it in. Do I have to get the hot dog first and then get my drink? Or could I get my drink and then get my hot dog or hamburger or pork chop? So here, for number one, the order there is no order. We just go and get what we want. So number one has to be a counting principle. Has to be a counting principle. And the whole reason why it's a counting principle is because there's no order here. You have 3 types of meat: hot dog, hamburger, pork chop. We can go get that if we want. And then we can go to the drinks and we can get either Pepsi, Mountain Dew, Coke, or Sprite. There's no order there. Or, if I wanted to, I could grab my Coke first, then go back in line and pick up my hot dog, hamburger, pork chop. So there's no order. Plus, there's multiple different things going on here: hot dogs, hamburgers, pork chops, Pepsis, Mountain Dew, Coke, Sprite. It's not just one specific topic. It's multiple things. Hot dogs and hamburgers are not the same. Pork chops aren't the same. So anytime you have multiple things that don't have to go together, like you don't have to get a hot dog if you go think. You could get none if you want to. So that's counting principle. Now let's take a look at number 2. Plus, look at the wording. Here we're talking about a meet. We're talking about swimming, racing, things like that, because they have order when you win. So the key here is these both have racing in them, swim races, okay, or swim meets. So they have to be permutations, combinations. Order matters, order does not. If the top 3 people advance, there's our key right there. Top 3 advance. Is there a specific order that those 3 players have to be in order to win? And the answer is no. Think about it. If I come in 3rd place, do I still make it to a championship round? My time may not have been as good as the one who finished first, but it doesn't matter because we all are equal in this case. We all won the same thing. We won an advancement to a championship. So in this specific scenario, order does not matter because all 3 of us advance. We all won. Okay? There's no difference in what we achieved. We're all going to a championship. So this is order does not matter. That is a combination. Now, a lot of times we write combination, real simple. You take how many people or how many things you're using. In this case, it's competitors. And you put that as a subscript. And then capital C for a combination. And then on the right hand side of the C for a subscript, you put how many you're choosing. So in this case, we're choosing 3. So this is how you denote a combination. You use subscripts, the first one being how many competing or how many total, and then the second number being how many we pick. Okay? Now, obviously, since we have figured out that the first one's a counting principle, the second one's a combination, the third one is probably going to be a permutation, but let's read through it to make sure. So remember, everybody advances if it's going to be a combination. No order there. But let's read this one. 10 competitors. Grand prize is first with gold, second with silver, third with bronze. So the key here is those 3 words. First with gold, that's the first set of 3. Second with silver, third with bronze. This has order to it because here's the thing. If I come in 3rd place and I get the gold medal, is it fair? And the answer is no, it's not fair because I am the 3rd best person. So order matters here because first place has to get the gold. You can't give gold to 3rd place. Okay? So order matters. So it's just like with a combination. We use the subscript and we put how many we have. So total. So there are 10 total. So let's put permutation first. So permutation. And we do how many we have total, 10. And since the last one was C, this one pretty simple. It's going to be a P. And then how many are we choosing? We're still choosing first, second, third. That is 3 places, so we are choosing 3. Okay, real simple and easy. Now, the real question is, which one do you think has more combinations? Now, obviously, counting principle we can count off because, I mean, if you look up here, especially with this one, counting principle, if you have a lot more items, it gets a lot higher. But when combinations and permutations, which one do you think would have the most? If order doesn't matter, so let's just say for a second, let's look at this. So combination. So say I had 10 players and we called them A, B, C, D, E, F, G, H, J. Okay. 10 players, if I'm not mistaken. Let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's 10 of them. And let's say A, B, C won. So they won. Is this the same as BAC or CAB or BCA? Are these all the same? Because the key there is, does order matter? In this case, it doesn't. These three would advance, so A, B, C are advancing. If B passed first, and then A, then C, they're all advancing. So these are all the same. These are all the same when order does not matter. If that's the case, then we can't count this as 4 different combinations. It's one. They're all advancing. A, B, and C are winning. Okay, that's what you got to think of this as. It's a group. This whole group wins. So this only counts as one combination. But if we talk about order mattering, A came in first here, B came in first here, C came in first here, and then instead of C coming in third, or C coming in third here, C comes in second. So this would be how many permutations? This would be 4 permutations. And it's all because this is a different order than this one. Therefore, these are all different. There's a different first place for 3 of these. Okay, so this counts. Each one counts as individual. And this is because order matters. It doesn't make sense. I mean, this guy's getting gold here. Here, in both of these, he's getting bronze. Totally different order there. So it's very simple. An easy thing to remember is when order matters, you will always have more combinations than if it was a combination and order didn't matter. Okay, something real simple, real easy. Now, the last thing I want to go over, now that we kind of got an idea of what this looks like, and this is the most, to me, is the most tricky type of problem to work, and it has to do with time. So we visit a college. There are 15 students going and 10 time slots available to meet with a professor. Now, the real question is, would this be a combination or would it be a permutation? Most people struggle with this. They have a really hard time. But here's all you got to remember, and it's the easiest way to think about it. If you go in for a job interview and your interview is for 9 o'clock in the morning and you show up for 10, does it matter what time your interview was? And the answer is yes. It definitely mattered what time your interview was, because I'll be honest with you, depending on where you're getting this job at, if you show up to an interview at 10 and it was supposed to be at 9, you're not getting a job unless you just absolutely blow them out of the water, or they don't care and they just need somebody really bad. Then you might get a job. But for the most part, you're not getting a job. So time matters. So this is one important thing you really need to remember. Time matters. Now, when I say time matters, what I mean is that the order of time matters. So in this case, let's just write up what this would look like. So we have how many total. So in this case, there are 15 total students going. It's a permutation because time matters. And then in this case, there are only 10 slots, so we're filling 10 of them. So So this is what our notation would look like for that permutation. Now, we're going to practice a few more, and then we're going to get into how to actually compute how many permutations, combinations, and using the counting principle, how many combinations there might be with the next examples.